Let's continue with the next part, texturing the rough surface of the Roku base. And that kind of like will set the foundation for also we have to texture the rough plastic part of the Roku remote. So there are two ways to create such a structure, either via an image or via a procedural texture. In Fusion, well, we have actually this surface, which I've selected here, designed in a way so it's rough. Let's go maybe to the render tab so we see this better. Let's zoom in a little bit, and there we see the structure. So that's actually an image. If we go to the materials and Roku plastic textured, that's the way how I called it. And here in relief pattern bump, there, that's the image. Copy this image out. We have this inside the texture folder. There it is. So this image we can scale up and down to adjust the scale of the rough surface pattern. And then we also have to tile this image. So we multiply it. Go to Blender. We will go with the base selected, go to plastic texture rough, and since Trayton asked for it, whoops, no, 50, I want this one to be there. We will use a little bit of nodes again. So the timeline we will set to shader editor. Let's zoom in here a little bit. And down here we have something called normal. So the normal is what will be used to roughen up the surface to give it that three-dimensional look. Let's create a texture. And into this texture, we load that image. And where is the file? There it is. Very good. Okay, so this file now we have to use to adjust how strong this bump effect is. So for that we need a bump command. Let's go to add, to vector and bump. Put this in between. Connect color to height. And then normal to normal. And we go to there, and there we can see this already. So if we disconnect this, no, this is just rough. We add it to there, and there we see now that actually we have this bump mapping. If I zoom in too much, you see we can look into the camera. If you press N, in case you don't see the properties panel, go to view and clip size, set this to 1 millimeter. Okay, closer. Well, not too bad. So to adjust the strength, well, we simply manipulate this value here. The more we lower this, the less effect. The more we increase this, the stronger the effect. We can also go to 4, then actually this effect is too much. Maybe 0.1, it seems to be fine. Okay, so let me pause here for a moment and let me explain to you what this bump mapping means. The surface is still flat. And to simulate all these cavities and hills, the software, by using this image, simply creates fake highlights and fake shadows. And when we zoom in here a little bit, it's basically what you see, all the shadows. And that gives you then the illusion of that being a structured surface. But it's literally just a visual effect because it's flat. Okay, so let's say we would like to adjust the size of this pattern. So we need to scale how this image will be replicated or tiled over the surface. So I can move this to there, move this to there a little bit. Then I go to add vector and mapping, because with mapping, if I zoom in, we can move, rotate, and scale a texture. Connect vector to vector, and then we go back to input, texture, coordinates, and connect UV to UV. What UV is, I will cover at a later point in the video. But all the meshes that come via OBJ exported from Fusion have the UV properties already added. Okay, so if we disconnect this, whoops, what happened? No, that's not what I wanted. If I disconnect this and add this again, we can see the effect a little bit. Now let's set this to 3. You see that makes it finer. 6. And even finer. But no, the problem we can run into is tiling effects and also a Moire array. A Moire array is what we see right here from happening. Keep in mind, our displays are very low resolution. The image can have such a fine detail that it will create these Moire arrays. Now let's take a look at how this looks through the camera and do a final rendering. 700 by 500. Let's set this to 150%, so the image will be a little bit bigger. That's fine. And then we click render. We'll have to wait a second, and yep, there we see that problem. Let's see, we make this 300 and render. And you see that Moire array effect is less noticeable, but now we can really see how everything is tiled. So and I wanted to show you this on purpose. This tiling can actually happen when we use an image as a base. And then the smaller we make the texture, the more this tiling can happen. So you see this is actually not as strong, but it's still noticeable. If we set this to 1, let's do the rendering again. Yeah, it's not that noticeable anymore. But then the pattern is a little bit too big. This is bump mapping by using an image. Now in your Blender file, let's move all this to the left. So I hold the Shift button, click these 3 nodes, press G to move, and then I disconnect this one. And what we will do now is go add and texture, and we will use, I can't pronounce this correctly, Musgrave, however, that one. And we connect factor to height. And maybe to 1, and scale maybe to 50. And also here, this we can copy and bring this over to there. And there we are. Very good. Okay, so 0.2. I just needed to add this texture coordinate again. So here, via the scale, we can adjust how big this effect should be. Now, what's the difference between the image and this procedural node? Let me give you one quick demo. How do we do this ideally? Yeah, I do it this way. this and this. I select Shift D, move this over, select this one, Shift D, bring it over. So I just make a copy of these two elements and then connect this one and click Material Output. And I also have to copy this one over, and there we are. Okay, so if I set this to 1, you see we always get a super refined, not super refined, super sharp image or texture. And that is because this result is generated by a math formula. So this is actually resolution independent. I can texture an infinitely big object and this texture will simply flow over it. With an image, that doesn't work that way. Because image is made out of pixels, it has a resolution limit. Musgrave is one. We also have others, for example, Voronoi. There, there. Looks like a cell. You can also set this as cells. Also here again, we can adjust the size. It's like different procedural, so mathematically based textures we have. We also have a noise effect. I think that's just, yeah, just a noise. Also here, scale can be adjusted. Okay, I hope that this basically explains it. It's not image-based. This mathematical function creates that image for us. Okay, very good. So let's do a quick rendering and see how this works. And there we are. Pretty good. I mean, you see there's no tiling or anything happening. So that's perfect. Very good. And that basically, in a nutshell, is what bump mapping is when we want to create fake highlights over something. We will do the same now with this tag. If we zoom in a little bit, purple image isn't good enough. It has actually a material structure on it. And here we do not have that image inside. So I will copy this one out and then supply you this actually. So here's the fabric, advanced, fabric, wire, normal. Okay. So I want to go to library, application support, Autodesk, and for fiber. And there we are. What do we have there? There. Yeah, this is very good. Okay. These two to my desktop. Textures, make a copy to there. Very good. Okay. Blender. So I would like this texture to flow over it. Let's move this one to there, to there. So we do the same, add input texture, open, let's go to textures. Now we can maybe work with this one first. Let's see how this one looks. There, then Shift A, vector and bump. Very good. Connect this to there and there. And let's zoom in a little bit. So now we can see what's happening. I would like to scale this a little bit more. So Shift A, texture coordinate, Shift A, vector and mapping. You see the steps are always the same. So at the beginning, this might be confusing, but You do this 2-3 times, it becomes second nature. So it's not that complicated then. It's just new right now, so it seems odd. Okay, so maybe 6. And we have kind of like a woven structure on it. That's not really 100% the way how this the real piece is, because we would need the right fabric pattern, but that's okay. Let's actually open this image. And whoops, now go to non-color data. Just want to see how this works. Yeah, this is a tick better. Okay. Very good. So we see like a woven pattern. Now, I mentioned before, this is all fake. So you can see that it's totally flat. Don't do this necessarily now, just pay attention to what I'm doing. This, just move to there. And we have something here called displacement. I need a math node. This goes to there. Multiply. This goes to there. This I disconnect. And let me see if this works. And then value 1, value 0.1. Yeah, it doesn't do this. Interesting. Okay, never mind. So what I will show you in a later exercise when we do this part more correctly. I'm going to open the browser and take a look at some images, and yeah, for example, this is a good case. Open image. Okay, I will just do it this way, make a screenshot so I can open this there. This is like only with a color, this is with a bump mapping, and this is with displacement mapping. And then you see the difference between both is bump mapping gives you the look of something, but it's not real. With displacement, it really deforms the geometry to make this a true three-dimensional structure. And generally, this is more realistic, but very memory intensive. But for a small piece of like a cloth tag, like in our case, this is actually more than fine. But we will revisit this at a later point. So for the moment, let's simply use the bump. Very good. And then here, let's give this a color. There, this is polyester. So let's make this nicely reflective. Maybe a little bit less, maybe a little bit more rough. Oh yeah, there we are. Okay, doesn't look too super good. Well, we will fix this at a later point. But okay, so that sums everything up for the basic introduction into bump mapping using an image, like for the grain, or here for the fabric, or also for the grain using a procedural map.